So our first topic, I should say subtopic on the financial mathematics, will be percent change. Remember the other day, our discussion, we talked about, the importance of percentages in business jargon. Uh, and you hear people talk about percentages in the business world so much. Perhaps you hear gasoline has gone up by 10% in the last month. Sometimes you listen to the advertisements on the radio or TV and they say Courts has 40% off this week. You want to know, what do these numbers really mean? What do these percent change really mean? Understanding, how data changes from one period to the next is a critical skill that you as business people should be able to master. What it allows you to do is to make quick assessment as to whether matters are improving or getting worse. It also allows for easy comparison of changes in different types of data over time. So we're going to spend a little time talking about the concept of percent change, right? Which basically the calculation will tell us how things are changing between 2 points in time, right? And we're going to talk a little about that. And then we're going to go on to talk about the rate of change over time now. And what this is going to do is going to allow you to, determine how things are changing over multiple time periods or multiple points in time, right? And that one is going to be a little tricky, right? So let's get into it, right? So this is a very nice formula that we can use to calculate percent change. So let's see if my pen is working. Yeah. So what this formula is basically saying that if you're going to calculate percent change, that's what symbolize it by that little, this is delta, Greek letter delta. And it's usually used in calculus. Somebody's asking about calculus. It's used in calculus to mean a small change, right? So change in percentage, right? Or a percent change. You take the old value, the new value, minus the old value, over the old value times 100, and it will be wrong for us to show percent sign at the end. Right? So remember this formula. Percent change is equals to the new value minus the old over the old, because that's the reference. Old value is always the reference. You're comparing the new to the old rate, how has it changed as a percentage of the old? Yeah. Let me erase all these right here, because I don't want to leave them on my PowerPoint. Good. So remember the formula. Let's use it in a problem or two, right? So look at this problem. So they're telling you that in 1982, the average price of a car in Canada was $10,668. In 2009 now, that has increased to $25,683. And you want to know what percentage has the price of a new car changed over these years? A long time, right? How has it changed? So you want to get some data, old value is that, the new one is that. So our formula, right? This is the new, that's the old over the old times 100%. I don't know why I'm putting the percent sign there. And this here, you put it in the calculator, right? And I'm hoping that all of you can actually use the calculator to do something like this, right? If you can't, and you're having difficulty with this, as a matter of fact, any example that we discuss in the class, when we have the tutorial session, that's the purpose of the tutorial. I'm not going to teach anything new. If you have any questions about examples we do here, well, jot them down and we're going to discuss them during the tutorial, right? If you have difficulty, man, sir, how we got from here to here, right? Ask me then, I'll clarify, because you can't ask me now. So when you calculate that, you have 140.748%, right? And you can give you an answer line here. Very simple. That's an application of the form. Good. Let's go to another problem. So you have a situation here, you purchase an item and there's always, always a sales tax sometimes on items, if we call it VAT here. Right? So in this case, the person buys a little machine to use in the gym, right, to exercise, and it's subject to some kind of tax probably over there, right? 13% sales tax, right? And you want to know how much you will end up paying, or this person will end up paying for the Bowflex. I'll tell you what, I noticed in Guyana here, what you see happening is that they normally work out the tax. We're hoping that they did it correctly, right? And they're being truthful and they put it in the price. So when you go, they say that is VAT inclusive. They use that term. And the money you pay already has the tax inside, right? In other countries, and I shop online a lot, and I notice it, and maybe if you have traveled internationally, you see it. They put the price tag like the $7.99. And when you go to the counter and the computer does or adds on the tax, then you get a big surprise, right? Get a big surprise because tax is added on. Sometimes you don't have the money in your pocket, right? I see it a lot on online shopping. You see a price for a thing, and when you put it in the cart and you go check out, you see a whole new thing because they add on tax, even shipping and all. So you get a big shock, right? So it's how they do things and how we do things, right? Yeah. All right, let's get on to the problem. How much you end up paying for the exercising equipment, right? So it starts off by saying that, all right, this is what is written on the item. You have to pay $7.99. But there's a tax. That is the change, the percent change in the price you will have to pay at the checkout, right? So if we were to go back to our formula, we know this, right? We know the oil price is the mark price, but we don't know what we will have to pay at the counter, right? When we check out. And that's what we have to find out, right? So I put it in the formula, we have to find this, right? So, all right, the 13% is 0.13. Right? What did they actually take over the 100, right? Take over the 100 over there, right? And divide, right? Yeah. And they take this 799 and then multiply by the 0.13, and you get 103.87, right? Well, so you now end up with 103.87 equal mu minus 799. You take this over, take that over there, and you add it on to that, and you will get your 902.87. So that's the price you have to pay at checkout. Right? I know in Guyana here, sometimes we do it this way. You see this in school a lot. If you have to pay a 13% sales tax, you find 13% over 100 times what is it? 799. 799. Right? I'm not putting the zero. Doesn't have any. effect on the calculation, and that is equal to $103.87. But this is your tax. And then you add that, right? You add that to your 7. So price paid at checkout equal the $7.99 plus the 103.87. $sign, you should get your $902.78. Right? Okay. Same thing. Thank you. Let's take a tour. And this one is a little more complicated. But doable. Don't get scared. And what I like about this one is it's something manufacturers do. Um, most of you here, maybe in later years, you will manufacture something or package something to sell, and maybe you will use the same tricks on us, right? So what they're doing here, sometimes they're selling something, and because of rising costs, what they'll do is they don't increase the price, but reduce the packet size, right? And consumers might feel, oh, they increase, but they didn't increase. They might even reduce the price, right? But you ain't check that they reduce the bottle size or the packet size or what is inside the packet. Sometimes the packet size is the same, but what they in the package reduce. Sometimes you don't realize it because you don't read labels, right? I'm telling you, some of you will eventually use that tactic on people in the future. Good. So let's take the problem. So as it's just what I explained to you. Consumers often object to price changes in many daily products, even though inflation and other cost changes may justify these increases, right? To reduce the resistance to a price increase, many manufacturers adjust both prices and product sizes at the same time, right? So this is a good example. So the regular price of a bottle of shampoo was $5.99 for a 240 ml bottle, right? So to account for the cost changes, and so the manufacturer decided to do this. It changed the price or reduced the price in this case to $5.79. So you think, oh, can get cheap, you buy a whole set. But guess what? The bottle reduced in size now to 220 ml, right? So out here, $5.99 was for the 240, but they reduced the price, but they reduced the volume. So you might want to analyze now, well, what has happened here, Ray? Did the thing got cheaper? You know? So what is good to examine is what the question asks you. What was the percent change in the price per milliliter? That's a good thing to, break it down to the smallest unit. How much in these two bottles, how much for each milliliter here, right? So, okay. That's all we want to calculate. So let's get, what they give us. This is the old price, the old size. New price, new size, right? So let's calculate how much per milliliter you pay. So the old one, old price divided by the old size gives us 0.024958 dollars per milliliter, right? New one, as a new price, new size, gives us this. And what you see happening is that the price has actually increased from here to here. You see, there is an increase in price. It looks small, yes, but remember you're dealing with milliliters and you multiply that to become liters. There's a lot of increase, right? So your percent change now, right? You put in your new price minus the old price, the new minus the old over the old times 100%. and look at what happens. You get a 5.4485% increase. So even though price of the bottle, the smaller bottle, is less, there was an actual increase per milliliter. Actually paid more per milliliter. Right? Neat trick by manufacturers. Right? And as I said, some of you will do us that when you become entrepreneurs and businessmen, manufacturers and packagers. Right? I wish you well, but you will end up cheating us too. It's perfectly legal. It's perfectly legal. People have to read the package, that's all. All right, let's go to a little more complex concept now when it comes to percent change. And we'll talk a little about rate of change over time, right? Rate of change over time. So what are we dealing with here? So sometimes we have when we talked about that population growth just now, right? That was over many years. That occurred. So sometimes people want to know, well, instead of what's the percent change over a long period of time? Well, they want to break it up and say, all right, what happened in the first year? What happened in the second year? What happened in the third year? You know, that sort of thing. So people want to break it up into what is the average rate of change over a particular period, right? Over on a yearly basis. And that's what this is about. Rate of change over time. It's not an overall rate of change, but it's like an average rate of change over smaller periods, right? So this is the formula here. And notice this formula is not so straightforward like the previous one. It involves, we say this is a logarithmic change now, a logarithmic change, right? It involves some logarithms. You have to find the root here, right? So it's the square root of the new over the old, the nth root, that is. Did I say square root? Sorry. The nth root, because it depends on, the time period, right, that you're considering. Minus 1 times 100, and you can put in percent. Good. So let's see if we can use this formula, right? Let's take a problem. Good. So this here involves population growth, right? So in 1996, we have 4,263,759 people. In 2006, that has increased to a little over 5 million there, right? You want to know, calculate the annual percent growth in the population. Notice what they're asking, not the overall percent growth. They want, what's the average annual percent growth in the population, right? So that's what they want. And what you have to keep in mind here, right? This here is a logarithmic growth, right? So I think we talked about something called exponential growth, right? If you were to put money in the bank, it might look like that. But then populations and so sometimes grow logarithmically, right? They grow like this, a little slower, not like this, right? Not like that. Keep it in mind, right? This is logarithmic growth. Now, the growth changes from year to year. The growth changes from year to year, right? The rate of growth, because when you do calculus, you'll see that because it's a curve, the gradient here, the rate of growth here is different from the rate of growth here. It's different from the rate of growth here. But what this formula does is it gives you an average of all those different or those changing rates, right? So while, it might be tedious to calculate the rate every year, we kind of get an average rate of growth, right? That's what we're going to do. So we use the formula, so they actually tell you, okay, that was what it was. Now this is what it is. It has occurred over 10 years. So you put it in the form, right? The new over the old 10th root. Now this is going to be complicated. You have to check whether your calculator can actually find the 10th root of a number, right? I'm not sure very many calculators can do it, but you need to have a scientific one. If you have a program on your computer or phone that can do it, all well and good. But you can look on the internet for one, right? So when you do that now, then you finish with that, subtract one, right? And then the answer you get, you multiply by 100, right? So I was sticking at 100%, right? And your answer turns out to be 1.8, what is it, 332%, right? Yeah, so this kind of gives us a nice average of what went on, right? Each year over that 10-year period, right? It's like somebody said, on the average, like how much did it increase on the average? Yeah, I should tell you, I was talking there about exponential and logarithmic. Let me go back, sorry. Yeah. Exponential, okay. Logarithmic. Oh, yeah. So lots of times, and for those of you, you all might go up and you might want to invest your money in something, you know. Very often when you see people promise you that your investment is going to grow exponentially, right? I want you to be there, right? When people promise you your money is going to grow exponentially, very often they're out to con you, right? On the other hand, when you see somebody promise that your investment might grow slowly, right? They might use the word logarithmically, right? Logarithmically, right? It might be slow, but it might be more sure. It might be less risky, right? So this might very well be the better investment, right? Be very careful. Be very careful when it comes to investors and what they want you to invest in things, right? This one is fast, but risky. This one is slow, but it might very well be less risky. Right? That's a little pro tip I'm sharing with you. You might thank me later on in the life. Well, I want to go to a little more difficult problem that involves rate of change. This one, you're asking for a lot of things here. So this sounds like a girl, Kendra. She's collecting hockey cards and she's collecting the cards of this person Wayne Gretzky. He's a famous person over there, right? And maybe he has become famous, and that's why he's rookie year. You know, he just started out and probably scored his first goal or whatever they do in hockey. You know, a card like that will carry some value, you know. So okay. So it says the book value of the card vary depending on a couple of conditions, right? So it says that the estimated value of the card fell in the first year, then rose by $113 in the second year. Right? Stuff is happening. So they're asking us, what is the percent change in each year if the card is valued at this at the end of the first year? So this is very much like, say, old formula, not a new one of rate of change over time. No, this is the old formula, right? What is the percent change in each year? So they want you to take it piece by piece. First year, the second year. Right? Then they say over the course of the 2 years, what was the overall percent change? Right? What was the overall percent change? Right? So again, this is the same old formula. You're taking 2 years together now, right? So it's the same old formula, very, very simple. But this one here, this one, you have to use your new formula because you want the rate of change per year. The rate of change per year you want. Right? So let's see. Let's see how we're going to solve it. Give you some information. These are. So we kind of put down all we know, right? So say the price at the end of the first year is this. And we know that it fell by $84, right? So it was a little higher than 1,003. Fell by 84, right? And at the end of the first year, it's now $1,003.33. During the second year, whatever it was now, so it's what? 1,003.33. It increased by 113 in the second year, right? So they're telling us exactly what I told you before, right? Calculate the price at the beginning of the first year. That's not hard. You just add the 84 to the 1,003. It was worth more at the beginning of the first year, fell to 1,003, right? Then they ask you for the percent change in year one. I told you, we apply the old formula. Shouldn't be hard. Then they say calculate the price at the end of the second year. Well, you know what it is at the end of the first year. Add on the 113. That'll give you the price at the end of the second year. Very easy. And then the percent change, again, we use that same old formula, right? That new minus old over old multiplied by 100%, right? Good. And then they want the overall percent change, which again isn't very hard. You know, you take the at the beginning of the first year to the end of the second year was the price, and subtract them over the original price times 100. Again, is the old one, right? That's what they're telling you. Apply the percent change formula. Lastly, for the rate of change over the 2 years, well, you'll have to apply the very difficult formula, the logarithmic one that has square root and so inside. Right, so let's see the solution. So we want to know how much the card was valued at the beginning of this whole transaction, like, you know. So at the end of the first year, it was 1,003, right? So the old minus 84 will give you that, right? So you bring that over here, you add it, right? It's like you're adding on $84 to 1,003 dollars and 23 cents, and you get $1,087.23. So at the beginning of the first year, that's it. That was the price. It decreased by $84, and that's how it actually become this at the end of the first. So the percent change, you put it inside the formula. This is the new, this is the old, this is the old, times 100%, and you get, notice, a negative value. The thing went down in price. So your percent change is a negative. Yes, you can have a negative percent change, right? But then in the next one, the next year now, okay, we got it old. Well, that's the 1,087. Sorry, not 1,000, 1,003. And it increased by 113, right? So in the second year now, the price is going to be that. So it started with this and it ends with that. So the percent change in the second year is going to be this minus what it began the year with, over what it began the year with times 100%. And we got a big increase now, 11.2625%, right? So you see, in the first year, there was a decline. Second year, it was an increase, right? An increase of the price, right? And this should tell you something when it comes to investing, right? And I give you a nice pro tip here. When it comes to investing, you have to play the long game, right? You can't see already there was a slight decrease in the fourth year. You're ready to chuck in and you want to pull out your money out of the investment. No, right? Hold on, like this girl probably should see the man is still in the game, right? And he's doing well in his practice sessions and his smaller matches. And so say, you know what? This card can go up, I can hold on to it. And she gambled correctly, right? She bet correctly and watch. The thing increased the second year by a whole 11, right? So overall, for the 2 years, there was an increase. See? So keep that pro tip in mind. When it comes to investing, play the long game, right? Play the long game. Yeah. And then, okay, the overall for the 2 years now. So originally, this was the price. The end of 2 years, that's it. Over the original times 100%. So you have an increase of 2.6671%, right? That's an overall increase. But you want a year by year, an average year by year now. We'll be using our rate of change over time, right? So you kind of get an average now of every year how much it increased. So even though in the first year it decreased and the second year it increased, you do have an overall positive increase, right? That's what you look for on investments. You want to look at, okay, don't watch that 1 year was a bad year. Take, as I said, take the long game. Take several years, right? 5, 10 years and see what happens, right? And as you see in this case, there's an average of about 1.3248% per year, right? Yeah. So that's what that formula actually does. Tells you an average per year, right? So all the information is kind of summarized at the bottom here, right? And I think the question has some value for those who are thinking of things like, you know, investing, play the long game, keep that in mind, right? So a lot of people in other countries, they would invest, you know what they call them? Fortune 500 companies or what is it, S&P 500 or something like that. Those big companies that over time, if you were to track them over 5, 10, 15 years, they never really make a loss overall. Maybe 1 year they do bad, but overall they do very well. Right here in Guyana, I think, companies like DIH, DDL, they make around 10 to 12% profit every single year. That's very, very good. That is far better than what the bank offers. You know, the bank offers like the highest interest rate you get from a bank is probably about 2.5, 3%, right? Of course, there are differences, right? You could just go over to the bank and tell them, hey, I want my money next week. But with buying stocks, right, or buying shares, the banks, the DDL to recover your money takes a process, right? Takes quite a bit of time and paperwork and all of that, right? So while they give you a big return at the end of the year, to just go and put out your money like that, that is. Yeah. But investing in those companies that do well year after year, very important, right? So as you see in this case, the investment of this person grew by 1.3% each year. I'm not using all the decimal places, right? Yeah. So that's for a little bit there on percent change and rate of change. Because rate carries the time factor, right? Time factor. Not an overall thing, but what happens in an instant of time, right? It's very important. So we'll stop there with this one, and I'll see you in the next one.